Okay, so as promised in the previous video, we looked at drawing up some simple interest graphs, and here we're going to look at doing the exact same thing, but looking at a slightly trickier concept, which, as we've looked at before, is compound interest. Now, before we do anything, like I did in the last video, I'm going to just write out the compound interest or future value formula that we talked about. We said that we can get the future value by taking the present value and multiplying it by 1 plus the rate to the power of the number of compounding periods. So this was one part of the topic where we said we can find some value amount, some kind of future value as we discussed. But remembering that with simple interest, this just gives us an interest back when we look at the formula, I equals P times R times N. This time, we're not quite given the interest back, we're given just the value of this present value in the future. So it's gone up by some amount. That amount it's gone up by is the interest. So we had this second kind of formula we talked about, which was that we get the interest by taking the difference between the future value and the present value. Because we take our present value, we add interest, we get some kind of future value. So we can rearrange the equation to make the interest the subject. Okay, so what we're going to do, the hardest part of things like this, which I'm going to run through slowly in this video, is actually figuring out how we can make this particular formula of I, our interest, versus N, the number of compounding periods that we talked about. So this is going to be a little bit trickier to set up than just the simple linear relationship we did in the previous video. So there's going to be two parts to this. So first of all, we want to look at our question, and it's asking us to draw a graph showing the interest earned over a period of 10 years if $1,000, this is our principal, is invested at a compound interest rate of 8% per annum. So what we're going to do to build up to this, we're going to use both of these formulas. First of all, before we can even think about the interest, I want to find the future value. So our future value with these amounts that they've given us is going to equal to my principal, which was 1,000, times 1 plus 0.08 to the power of n. Okay, and I can simplify that to be 1,000 times 1.08 to the power of n. Okay, so we're halfway there. We've come up with an expression for the future value. That thing we can just put in place of the future value here. That's the connection between our future value formula and our interest formula when compound interest is required. This future value minus the present value. But now remember, the present value is just the principal, the initial thing that's put in. So I know this present value to be, from the question, 1,000. Now we can put everything in. Now, I'm just going to color coordinate this a bit better so you can kind of see what I was talking about. This entire expression for the future value that we came up with, 1,000 times 1.08 to the power of n, that guy is going where this bit is here. This is our future value, right? So when we write out an entire equation combining these two ideas, we're going to get that our interest is equal to this future value thing that I've underlined in blue, 1,000 times 1.08 to the power of n minus my present value of 1,000. And this is the thing that we're going to be graphing. So it's a little bit weird, but the same principle applies We know that interest is always going to be our future value minus our present value. There's just an extra step because we need to do this whole business over here to get an expression for the future value. And that's what we're putting in this first part over here. That's my future value. I'll actually write that in. And this thing over here is my present value. So now that we have this thing here, we can set up a table of values and draw this thing out. So I'm going to draw up a table of values, and I'm going to include 3 things here just as you sort of start getting used to this. I'm going to have my N, my FV, my future value, as well as my interest. But what I'm actually graphing at the end of the day is my interest against my number of years or compounding periods. So I have my N, I have my FV, and I have my I. So I'm just going to split this as 0, 2, 4, 6, 8, and 10. And I'm going to write in all of these. So substituting into just my future value thing, if I put where this N is 0, I'm going to get 0 out. Oh, sorry, actually, I'm going to get 1,000. Because I'm going to get 1,000 times 1.08 to the power of 0. Put that in your calculator, you're going to get 1,000. Substituting in the 2, I'm going to get 1,166. This is just substituting into this first future value formula we had here. That is this particular row that I'm doing. And I'm just going to write in these values, but you can pause the video to have a go at this on your own if you're working through with me. But I get all of these values, 851 and 2159. Now, the thing I actually want as my y-axis, the interest, I'm going to take all of these things here in my future value column, and as we can see in this I equals 1,000 times 1.08 to the power of n, the future value, all I'm going to do to each of these numbers is take away 1,000. That gives me my interest. So this is going to be 0, and as I go through, you should see that all of these numbers here are just 1,000 less than my future value. I get 851, and I get 1,159. Now, in an exam or in your books, you can draw some really nice grid paper, but I've gone ahead and graphed this in Desmos so you can see. But when we look at the actual relationship, at first glance, this could look linear to you, but this ends up being a type of what we call exponential equation, because this x here, or our n, as you can see, all I've done is I've replaced because on Desmos it works with x and y, I've replaced my I with y, the vertical axis, I've replaced my n with x. This n, or my x here, is a power. So I'm going to get this graph sort of shooting up like this. Hopefully you can kind of see that. It's not as quick of a rate as with some other exponentials we've looked at, but you can see that here, if I go across to different values of n, for example 6, I get 586, because I've rounded this up, 586.87, which is the 587 we came up with earlier. If I go all the way up to 10, you're going to see 1159 rounded up. So obviously the skill is you're going to have to remember how to plot these points, which we've looked at in the previous video, and just connect the dots. But the type of graph we're going to expect is going to have a little bit more of a curve to it, other than just the straight line. But the main thing I wanted to get us to in this video is understanding how we can set up this equation, this I equals 1,000 times 1.08 to the power of n minus 1,000. We're combining two different equations, the future value one, which gives us our interest in addition to the principal, and then apply that to make an interest formula, which takes our future value and subtracts the initial present value, which here was 1,000. Then it just becomes a matter of, now that you have this, and as you guys get more comfortable, you don't need this entire future value column. You can just substitute everything straight into here, this I equals this thing here, and get all your values of I down the bottom there. And because there's powers involved and they're not really nice numbers, you're going to get a lot of decimals. So here we've just rounded up to the nearest whole number. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.